Thank you, Jan, and thanks to Philippa and Jan and Alistair and the conference organizers for giving me the opportunity to speak to you today at this conference. I'm going to be talking about dynamic conservation and multi-benefit strategies, and I'm going to be using migratory birds as an example of species on the move. So migratory birds, of course, are the quintessential group of species on the move. They have hemispheric scale migrations, and this rather amazing piece of work just put out by Frank Lasorda at Cornell Lab of Ornithology shows the movement patterns, centers of distribution of 118 species of North American migratory birds. And you can see that as soon as the populations get to the Arctic to breed, some members of those populations are turning around and going right back. So these species are constantly on the move. This creates many challenges for conservation, and I think key among them as we think about climate change and habitat destruction is whether there are going to be places for these species to land in the future. So an example of this is in the 1920s, Sumas Lake in western British Columbia was drained for agriculture. This was a massive system. And for many years after that, locals documented the circling patterns of large populations of waterfowl that were searching for a lake that was no longer existing. So migratory species challenge us to develop new strategies, new approaches that are as dynamic as the patterns of their movements. And by doing this, we can also think about adapting to annual conditions and climate change, and also using these strategies to bolster and complement the existing protected areas network. If we do this with an eye toward the multiple benefits that these programs can provide, we can also seek ways to reinforce and create positive feedback loops around these practices, which can increase participation in these programs and ultimately lead to increases in the pace and scale of conservation, heading to the ultimate goal of making these approaches mainstream rather than a minority of activities. So my colleagues and I work in the Pacific Flyway of California. And the Pacific Flyway is a massive aerial superhighway that connects breeding areas in the Arctic with wintering areas along the southern route all the way down to California. We can illustrate this with this bird we're quite fond of. This is the Dunlin. It's an Arctic breeding shorebird. So they breed in the high boreal and Arctic regions. They come down to stopover sites in the Skagit Bay of Washington and eventually wintering areas in California. And along the way, they experience a diversity of habitats, and perhaps the weakest link in this chain is California, which is one of the most heavily altered landscapes on Earth. So the Central Valley of California, we've lost about 4 million acres of wetlands to agriculture and development. About 5% of the wetlands remain in some sort of refuge or managed wetland condition. So it's a pretty harsh experience for these birds. Here's what it looks like to them. Instead of seeing this integrated mosaic of wetland systems that they were used to in their ancestral flyways, they now experience this kind of a patchwork of various kinds of agriculture. We did a spatially explicit conservation plan for migratory water birds a few years ago, and we found that to sustain populations into the future, migratory birds in California are going to have to depend on agriculture for almost 60% of their habitat needs. Agriculture in California is very complex. We are the largest agricultural producing state in the United States. It's a $54 billion economy. It supports about 400 different crop types. Many of the crops have the opportunity to be managed compatibly for wildlife, and many of them don't. So in the north regions here, the Sacramento Valley, rice shown in blue, corn, and alfalfa, triticale, all of these are annual crops which have a lot of opportunity to be managed for co-benefits like wildlife. In the south, we've had an explosion in permanent crops. These are trees. This is nuts and pistachios and also table grapes. There's limited opportunity to manage these crops for wildlife benefit. Although there are juggernaut forces that pull at California's agriculture, global economies, industrial, agricultural corporations, many of the decisions about what happens on the ground, whether it's beneficial to wildlife or not, are still made by the folks on the land, the managers and the family farmers. So this is Josh Shepard. He's a farmer that we work with. He's a 5th generation rice producer in the Butte County region of California. And as conservationists, we want to have a conversation with Josh. we want to approach him with a proposition to make his farm more beneficial to our objectives, essentially to make it a sanctuary for birds. Now, there's a variety of ways to have this conversation, and we've been having this conversation for a long time with our agricultural colleagues. One of the key ways to do that is to propose to buy them out and to restore their property into a wildlife refuge. This kind of work, we've done a lot of it over the years at the Nature Conservancy with our partners. It's extremely expensive. We can also buy the development rights and have prescriptive uses that are beneficial to wildlife. It's not so important to look at the absolute numbers here, but protection as a strategy has real limitations in scalability. If we're going to try and make up the roughly 1 million acres of habitat shortfall these birds are experiencing, a protection strategy alone would cost about $10 billion. So after years of being in the habitat purchasing business, we decided to diversify a bit and look at programs that were temporary and see if there were ways we could increase the efficiency of temporary protection and do it in a way that was comparable to the benefits we get from long-term protection. So this is analogous to going on vacation. So when you go on vacation, you probably don't buy a house where you're vacationing. Maybe you do, I don't. But instead, we look for an opportunity to rent. And when we're looking for a rental opportunity, we use a lot of information to make those decisions. So in essence, what we really need to be effective in this space is something like Airbnb for birds. And so here's Airbnb for Hobart, and you can go onto the website. You can think about when you want to rent a place. You can think about, do you want an entire home? Do you want a shared room? You can think about, do you want to be in Hobart? Do you want to be in Sandy Bay? Do you want to be in Toronto? You have a lot of data that help you make these decisions, and we need comparable data to do this effectively in the conservation space. So I don't know about you, but when I'm thinking about powerful big data analytics, my thoughts immediately go to these people, obsessive compulsive bird watchers. So over the years, this community has been active in recording the locations of birds going back for over 100 years. And most of that data has lived in people's notebooks and on their C drives and been unavailable to the community of science and practice. Cornell Lab of Ornithology basically solved all of this about 10 years ago. And with the advent of mobile devices, the ability to geocode bird observations has really taken off like wildfire. So this is eBird observations. Their program is called eBird, starting from the year 2003. eBird is now collecting about 3 to 4 million observations a month. The entire eBird data set contains about 200 million records. It's one of the largest data sets we have on any biological phenomenon. And it's turning out to be something very powerful as we investigate these sorts of questions. I'm happy to say eBird is very active and alive and well in Australia. And one of the things we can do with the citizen science information that the Cornell team has really pioneered is use it to make predictive models of bird occurrence and distribution. And these are giving us insights into these migratory patterns that we've really never had access to before. So this is the northern pintail. It's a bird we care about in California. About 60% of the North American population winters in California. Here they are pouring out of their breeding areas in the Arctic in the summertime, arriving early to the Central Valley of California, and then to the Mississippi alluvial delta and the Gulf Coast. And so week by week, we can look at what habitat conditions are like for this animal. We've been working with the Cornell team to downscale these models to our study area in Central California. And the models are allowing us to overlay week by week the predicted occurrences and abundances of these animals with the protected areas network as well as other land uses. So already this is proving to be really powerful, that week by week we can look at the value of the refuge system here shown in green. It's small, an important archipelago in a sea of agriculture, as well as the agricultural systems of these animals. So here's northern pintail, pretty good concordance with the existing refuge system for this particular set of weeks, as opposed to, this is the long-billed curlew, one of the shorebirds that we work on, which is not at all benefiting from the refuge system. It's much more of a pasture specialist. Now these data become really exciting for us in making decisions about where and when to rent habitat when we put them together with other large-scale information. So we have a project looking at Landsat information to try and come up with a scheme for looking at the presence of surface water. So we're interested in wetland birds, and so knowing where and when the water's on the landscape is really important for our decision making. And this is some of the early results that we've just published using this methodology. It's this 10 years of information showing where and when water is available in the Central Valley. We use this information to create a return on investment scheme for where and when it's most beneficial to us to invest in shorebird habitat. So here in blue, we see areas that are predicted to have high shorebird occurrence, but for some reason, this time of year, don't seem to have water. That's the kind of intervention we seek where we can make a big difference and benefit the shorebirds in this region. Here's maybe a prettier look at this. This is the least sandpiper. This is the Shorebird model showing the abundance of this beast in the Sacramento Valley, and underneath it, the surface water potential. So this gives us a much more prescriptive way to approach this farming community because we have a better idea what we want and what the birds need. So now aligning our proposition with farming is really the challenge. Rice farming in this region already provides a lot of benefits for birds. It's a flood irrigated crop, and so there are times of year, of course, when the crop's growing, when it's basically useless to birds, but in the middle of winter, oftentimes this crop is flooded to decompose the stubble. One of the things that we've found out is that there are other times of year that could provide a lot of shorebird benefit that aren't typically managed for shorebirds. So basically, we use this information to approach our practice community and use a reverse auction to engage them in creating this habitat. Now, this was a pretty radical idea that we had to socialize with our farming community, so we did a lot of workshops, and we did an experiment. We called our program Bird Returns, and we had 3 basic ideas. Could we attract enough bids to run the experiment? Would the auction deliver cost-effective habitat, and will the birds respond? I'm going to go through this pretty rapidly to get to the multiple benefits that this work provides. We were happy to receive about 53 bids, of which we accepted about 40, about 10,000 acres in our initial pilot. And the auction was robust, it was cost efficient. It cost about 25% less than if we had paid every farmer the same price. So they were providing a cost differential based on the cost for them to provide this habitat. And it cost less than 1% of a protection strategy. The habitat looked pretty beautiful, and it supported a really diverse community of birds at this time of year. We got busy on monitoring this, about 2.5 times the number of species in our wetland areas as opposed to control areas. Shorebird Response was about 20 to 30 times the densities in our treatments than in the controls. And this gave us the confidence to continue running this and refine this. By expanding this program, we've been able to accept more bids and be much more highly selective about who we're working with and the shorebird benefit they're able to provide. Over the last 2.5 years now, we've done about 36,000 acres of habitat and engaged about 175 farmers. So this is a program that can be adaptive to drought conditions. It can be done in a way that's adapted to climate change as well. But it really comes down to decisions made by somebody like Josh Shepard here again. So we now have a model that's working where we ask Josh and his farming colleagues to do something good for birds. They put that practice on the landscape. The birds arrive. We're able to monitor the effectiveness of this program. But we're also creating a lot of benefits that are additional to that we're only now beginning to understand. And this is really key because the means by which these programs can be broadly scaled and sustained really depend on the other benefits. Particularly if our intervention, our payments go away, what's going to happen to that habitat? Well, already this farming community is using our habitat program as a springboard into conservation subsidies to think about branding and certification. Can they get a better price point for their product by branding themselves as being wildlife friendly? There are agronomic benefits. Having water in the landscape for longer helps with the stubble decomposition, helps with pest management. They get social license. They are a highly conspicuous water user in a drought state like California, so marketing their wildlife benefits is really important. Wildlife-based recreation, hunting, bird watching, additional potential benefits in water management, groundwater recharge. All of these can be identified and monetized and create a really positive feedback loop for the farmer, in which case it doesn't even matter whether they're understanding the benefits to the birds. It's just important to their business. So now we're developing new projects that are specifically designed to be multi-benefit. This is a project we're going to launch next year, which also looks at the benefits to flood management and water supply, all the while providing bird habitat and other wildlife habitat in this landscape. So a framework that's useful to think about this is looking at the benefits to people and the benefits to nature. Scott Morrison, my colleague at the Nature Conservancy, has come up with this and published it in Conservation Biology a few months ago. So if we think about our goals, diversity and resilience of natural systems, and the goals of people down here, if we're explicit about the biodiversity benefits we seek, we can do really targeted interventions. But also, if we're knowledgeable about the benefits that these systems provide to people, we can look for opportunities to create these reinforcing feedback loops, the kinds of virtuous cycles that are going to allow us to create places for these birds to land in a changing world. So I'd like to thank my colleagues at the Nature Conservancy, Cornell Lab of Ornithology, Point Blue Conservation, as well as the University of Melbourne and the Rice Commission that helped us with this work, and it continues. So I believe I have time for a question.
Yes, thank you very much.
Thank you.